Hi and welcome. This time around we'll be looking at a new tool I got. It's kind of a very limited use tool, but it also matches my limited space shop. It was purchased on Amazon and delivered on this mini box pallet. Came out in great shape, sent FedEx. Looks like just a couple bolts holding it onto these bottom spacers that a pallet jack can go under with the tines really close together. But the packaging is excellent. Cut the straps, gonna pop the lid with a mini pry bar. I know I've mentioned this before, but a mini pry bar like this is an extremely handy tool. I use this one more than I use the other pry bars, all of them put together. The top was held together with staples and they came out very easily. Spun this around so you can get a better look, and it is an Eastwood finger brake. And the price was only a couple $100, including shipping. It's only 12 inches, which is really limited, but I can't fit a full-size finger brake in the shop, any kind of brake. I'd love to have sheet metal tools, but as you can see, there's nowhere to put them. This little guy will be able to slide underneath things. It just means my projects will be very limited. But in the past, the way I did my brake jobs would just take a couple pieces of steel in the vise, crimp the part I wanted to bend, and then hammer tap them around this piece of steel, you know, with the vise closed. All right, let me get this open a little further and I'll bring you right back. Broke out the sides of the pallet. They did bolt it to the base, which is nice. Looks like only 2 bolts. So I'll remove those and be right back. Alrighty, so just looking at the beefiness of this guy, the top portions are welded. 1/2-inch plate steel here, looks like 1/4 inch here. This is some angle, that's hollow, not solid. The base is sheet metal, and it looks like it is about 90 thousandths thick, or about 2.5 millimeters, 2.25 millimeters thick. All the exposed parts came in a light coating of grease. The action of the top part that holds the pieces in place is very smooth. And looks like you can put a decent amount of tension. The bars that you use to bend are just welded into some angle iron here onto this 1/2-inch plate on the bottom. But you know, for $200, I'm still very pleased. Looks like it's got some sleeve bearings or some sleeves in here on both sides. The action is very smooth. The pin's held in by set screws on either side. All right, so the cams in back here let you set up the bend radius. There are some preset positions on here. You loosen these set screws and rotate this guy, and that'll let you adjust bend radius. That adjusts how far back this guy goes. Right now it's pretty close to the edge, and you have to be careful about minimum bend radius. This will do 135 degrees. It'll do 20 gauge steel, I think something like 22 gauge stainless steel, and 18 or 16 gauge aluminum. It's got removable fingers, so if you need to get in and do a box or something where one of these needs to be inside, to do an inside bend, it's capable of that, rather than just a plain brake that's got a bar across the whole thing. I'm still a novice using one of these, so I'll still need some practice. But I have a project coming up where I needed this. The side you adjust for material thickness, and bend radius also can adjust on the side here. And you got a lock nut and a double-sided nut here on both sides to adjust the up and down on this guy. And that's pretty much it. The quality for the price is pretty amazing if you ask me. Again, the brand is Eastwood, and that's just a quick look at it. Everything is well painted. It was well greased for shipping. The handle was off during shipping. I have nothing but good things to say about this time. Maybe after a little use I'll know a little more. An experienced sheet metal guy could probably tell you a lot more about what's good or bad about it. That is not me. I intend to get some experience, but currently have very little. I'm not sure if this is even going to work at all, but I have a piece of spring steel in here. I wanted to put a partial bend. Nope. It's pretty hard stuff. So I guess if I want to snap some pieces off, that's a good way to do it. I might have to anneal it first because I bend it on the vise. Also, the bend radius might be way too sharp for this, so I might play with that as well. But the motion here was very easy. This is 20 thousandths thick. So not very thick, but it was trivial to bend this. Let's see if I have another piece of sheet metal I can stick in here. I don't have any decent sheet metal pieces that aren't really large that I'd have to cut right now. So here's a piece of 65 thousandths brass, which I know is much easier bending than steel, but probably is somewhat similar to aluminum, so this should work. So let me see if I can get this guy in here. I'm not sure if the bend radius is set right, again, novice, but I'll show you the action. As you bring down the plates that hold here, it's hard to do this one-handed because I'm putting a fair amount of pressure, but as you bring this handle down here, it cams, and once I reach this point, it's got some sort of flexure in it, and it's applying a ton of force to hold the sheet in place, which is a pretty neat design. All right, so I got that locked in. Again, I think the bend radius is probably not right, and it looks like I'm going to need both hands to do this. So this is bending all right. This thing needs to be bolted down. Right now it's sitting here under its own weight, so I'm sort of holding it, but that's also very thick material, and it looks like I did a pretty decent bend there. Let me give it one more go, and I'll bring you right back, show you the results. There we go. That was a 90-degree or better bend. And if this thing was bolted down, I've got to find a place to put it where I can bolt it down, even intermittently. It'll make it a lot easier, so if I have to do any amount of work, it won't be so bad. There's the bend, and I loosened the cam, and that's about a 90-degree bend in some 65 thousandths thick brass, which I think is thicker than this thing, or right at the limit of what this thing can do. It's not bolted down, which makes it a little problematic. So what I did was I flipped it around, leaned my chest right here, and then pulled the bars to me, and everything stayed fairly stable, but I'm going to have to find some place where I can bolt this down when I use it. But pretty good quality bend from my limited experience. 90 degrees, and there's a little bit of crazing on this side. So the outside of a bend stretches, the inside of a bend compresses, and the very center line of a bend stays neutral. And so you got to take that into account. That's how one of the things you need to do, how you calculate bend radius for the material, is based on how much it can stretch on the outside and compress on the inside without cracking. Brass is easily workable, so this turned out really good, so I'm pleased. As I get more experience with this, I will bring you back, but in the meantime, I think this is pretty good quality for the money. I couldn't buy the raw materials for $200 and something and still make this, and that's ignoring my time and all their experience in design. So I gotta say, I'm pretty impressed. Thanks for watching. Hope to see you next time.